Hi everyone. So welcome back to our channel. So today we are going to discuss about the characteristics or the properties or the specifications of an electric vehicle battery. So generally these electric vehicle batteries are called as energy storage systems technically. So these energy storage systems are nothing but the batteries. So they need to have some characteristics, or they need to have some properties, they need to have some specifications to act like an EV battery. Let us try to look out these specifications of this EV battery. First one is the capacity of the battery. Capacity of an EV battery. So coming to the capacity of an EV battery, so this capacity are of two types. One is energy capacity, and next one is charge capacity. Okay, so first one is charge capacity. Let's try to see how it changes. So charge capacity. So charge capacity is generally defined as ampere hour. So how to write down the charge? We know the formula for current. I is equal to dq by dt. So this dq I can write down it as this is I into dt, where dq I'm going to call it as a charge stored in the battery. So charge stored in the battery is nothing but dq, and the units of current is nothing but ampere, the units of time is nothing but hour. Therefore the charge stored by the battery is nothing but ampere hour. So this is called as the charge capacity of an battery. Is called the capacity of a battery is ampere hour. That I mean, this capacity of a battery is nothing but how to define the rating of an battery. The rating of a battery is also nothing but ampere hour. The charge capacity is also nothing but ampere hour. So this is how to define the charge capacity. Next definition we can call it as the energy stored in a battery. Energy stored in a battery. How to define this energy stored in an battery? So energy stored. So how to write down this energy? Energy is nothing but watt hour. So here we need to write out generally if you use an inverter, the inverter shop, they call the specifications of a battery or the rating of a battery is ampere hour. But in EV industry, the energy stored in a battery can be defined in terms of watt hour. So what is the difference here you have is already energy stored is ampere hour, but we need to express in watt hour. So multiply this ampere hour with the system voltage. So voltage into current will constitute watt hour. So where watt hour is called as the energy stored in an battery is nothing but the energy stored in an battery. So now this term is generally used by the layman language watt hour. If you go to an inverter shop, they generally call the rating of a battery is ampere hour. If you use an electric vehicle battery, they generally specify the rating of a battery. If you take the example the Ola S1 Air latest 2024 model, the rating of the battery is 3 kilowatt hour. You can see here how it is defined is in terms of energy, which is nothing but energy stored, which is nothing but watt hour. So 3 kilowatt hour indirectly it means that it is going to consume 3 units of electricity. It is going to consume 3 units of electricity per single charge. We charge it, it is going to consume 3 units of electricity, where it is called kilowatt hour rating. This is nothing but energy stored in an battery. The first specification is the capacity of an EV battery. This is how to define the capacity of a battery. First term is ampere hour, next term is watt hour. Second term what we are going to claim is nothing but the next specification of batteries. So total power output. So total output power rating of a battery. So total output power rating of an battery. So how to decide this total output power rating of a battery? It depends upon the charge and discharge load. So depending upon the load, automatically it is going to define the total output rating of an battery. So next one is nothing but the discharge time. So what is the time discharge time of an battery? So third one is the discharge time of an battery, which is very much important. So the discharge time is nothing but it is defined as the amount of energy stored in a battery. So how to define the energy stored in a battery? So this is nothing but energy stored in an battery. So this is defined as the energy stored in an battery. So what is energy stored in a battery? Volt ampere hour divided by the maximum amount of power delivered. So maximum amount of power delivered. So the units of power delivered is volt ampere. You can see here you are going to get hour. This hour is nothing but discharge time of an battery. So if you take an example of an 100 Ah rated battery, this battery can have two discharge time. So first case is 10 amperes of current it can deliver in a time of 10 hours. Here the discharge time is 10 hours. Same battery can supply 1 ampere current and it can deliver 100 hours as backup. So which is greater? That here the discharge time is greater. This is how to define the discharge time. So same, this 100 Ah battery can supply 10 amperes current for a time of 10 hours, or it can supply 1 ampere current in a time of 10 hours. That's how to define the discharge time of an battery is energy stored in a battery is volt ampere hour divided by the power delivered by the battery. It's nothing but the power delivered by battery. The power rating is volt ampere. Volt ampere will get cancelled out. That's how we are going to calculate the discharge time of an battery. Next specification of an battery is state of charge. State of charge. So charge means how much this. What is this state of charge? In general, it is called a shortcut as a SOC. SOC. So what is state of charge means? This is nothing but the how much amount of charging is available in an battery is called as a state of charge. This is indicated in the display in percentages. So you have an user display and this will be indicated in terms of percentages only. So this is called as the state of charge. The state of charge of a battery is indicated in percentage. Okay, so this state means what is the charge state? I mean how much amount of charging is available in percentage is called as the state of charge of an battery, which is called as SOC. For example, you have an healthy battery and in this healthy battery only 80% charging is shown in green color. So only 80% of charging is available. Now how much amount of charging is available is how much? It's very layman language. 80% is available. This 80% is called as a state of charge. And how much has been already completed is called as a 20%. And this 20% we are going to call it as a depth of discharge. So how much depth it has been discharged. So when you combine this state of charge and when you combine this depth of discharge, it will be approximately equal to 100%. So the state of charge of this battery what we considered is 80%. The depth of discharge of the battery what we still have is 20%. So 80 plus 20 it will constitute what is the total amount of charging available in the battery is 100%. It is called as the state of charge of an battery or complete charging. So second one is already very clear in the above. So next one is depth of discharge. What is meant by depth of discharge? The name itself says that in shortcut it is also called as DOD. So what is DOD means? This is the amount of charging is already discharged. How much amount of charge has already discharged? From here you can see here I have been taken this battery as an example. So how much amount of charging is available in this battery? 80% is available. How much has already discharged is 20% of charging has already discharged. This is called the depth it has been discharged. So the depth of the battery which has been discharged is called as depth of discharge. If you add state of charge and depth of discharge, this will be equal to 100%, where 100% is nothing but the battery is fully charged. In fully charged condition, it is available, where it is called as a fully charged battery, where it is called depth of discharge. And next parameter we have to understand in battery parameter is nothing but self discharge rate. Self discharge. Okay, so what is this self discharge? So self discharge also plays a major role. You can see the revision. First one is capacity of a battery is ampere hour. Next capacity of a battery is watt hour. Next one is output power rating of a battery. It depends upon the type of loads connected. Next one, discharge of a battery is nothing but energy stored in a battery to the power. Automatically you can calculate the discharge time of an battery. Next one is state of charge, is amount of charging available. Depth of discharge is how much it has been already discharged. Next one is self discharge. So this is nothing but the battery is there. So you take an healthy battery which is having 100%. So I have been charged your mobile phone, and this mobile phone has been kept in an locker without using it. So when you remove this mobile phone, so here you can see here how much it has been discharged. Okay, so generally this will be around 4%. Okay, so generally if you take an lead acid battery or lithium-ion battery, it has a self discharge of 2 to 4%. Let's try to consider the nominal value, which is 2% per day. For example, you the amount of charging available in our battery is 100%, and you have kept in the locker for 1 day, and so in 100 minus 2 is 98% of charging is available, and how much amount of percentage discharged is 2%. This 2% what happened? So here what is self discharge means, so this is nothing, self discharge is nothing but the energy lost by the battery whenever not used for longer time. So if you're not using it for long time, for more time, when you're keeping it in ideal mode, automatically it undergoes own discharge. It undergoes self discharge, or it undergoes self discharge or own discharge, which this 100% amount of charging available is decreasing its charging level to 98% in 1 day. So if you go for 2 days, automatically so this will go to 4% discharge, and 96 amount of charging will be available. So when you're not using a mobile phone for longer time, maybe 1 day or 2 day or 1 month, so around 2% of self discharge occurs per day. This is called as self discharge. And next important parameter is nothing but the life cycle of a battery. Life cycle of a battery. Life cycle is nothing but for example, if you take this life cycle of a battery, so a one cycle of a battery we are going to define it as so once the battery is charged to 100% from 0% to 100%, it has been charged. From 100% to 0%, once again you are going to discharge. One charge cycle and one discharge cycle, one charge and one discharge of a battery we are going to call it as a one cycle. This is called one cycle of a battery. So when you take this one life cycle of a battery, so life cycle of a battery generally defines the durability of a battery. How much life it is going to define. This defines the durability of an battery. It depends upon the number of times it has been charged and discharged. Okay, so generally if you take an example, so the EV manufacturer define their life cycles as 1000 to 3000 life cycles. So how to understand these life cycles? So for take an example, 1 day you are using your electric vehicle. Once you have been charged, once you have been discharged, so one cycle has been completed. So per day I am using one cycle of battery. So for 1 year, how many days we have? 365 days. Okay, so 365 into 3, approximately you are going to get, so we have 365 days, and for 3 years, so you are going to have 1095. So this is nothing but 3 years. Okay, so this is 3 years. 3 years, I mean 1100 life cycles. So every day you are charging once and you are discharging once. How many years you can use our battery is 3 years, and this is nothing but 8 years. So 365 days into 8, on average you are going to get 2900, approximately make it as 3000. So the maximum life a battery can come for us is 1000 cycle. Indirectly this 1000 cycle is nothing but we can use it for 3 years, or the number of cycles we can use it for 3000 hours or 3000 life cycles, which is nothing but in generally for duration 8 years. So the life cycle of a battery varies from 1000 cycles to 3000 cycle. 1000 cycles I am going to call it as a 3 years lifespan, or next one you are going to call it as 8 years lifespan. So this is nothing but the life cycle of an electric vehicle battery. So next one we are going to define about the, already we discussed about the ampere hour efficiency of a battery. This will be generally approximated to nearer to 100%. So ampere hour efficiency of a battery is nothing but the ampere hour rating of a battery, ampere hour rating of a battery to the battery discharge. So what is this discharge mean? Generally efficiency we can call it as output power to the input power. What is the output of a battery? So it is nothing but the battery has been discharged divided by the ampere hour rating of a battery charge. So for example, if you take an example, so the ampere hour rating of a battery discharged is 100% has been discharged. What is the capacity of the battery? 100%. How much it has been charged? And you keep charging, 100% will charge. So into 100, when you multiply it, you are going to get it as 100%. Therefore the ampere hour efficiency of a battery is 100%. Similarly, you have watt hour efficiency of an, so watt hour efficiency, which is called volt ampere hour, or watt hour efficiency of a battery also equal to 100%. Is nothing but watt hour rating of a battery discharge to the watt hour rating of a battery charge. The watt hour rating I am going to take it as 100 watt hour divided by 100 watt hour into 100. So this is expressed in percentage, where this is called watt hour efficiency of an battery. This is all about the efficiency of an battery. Next one is the size of a battery depends upon specific weight, specific power and specific energy. This is all about the parameters of an battery. Let's try to recall what are the parameters of a battery one by one. Okay, so the parameters of a battery are nothing but very simple. So specific power, specific energy. Next one is the capacity of a battery. The capacity of a battery is ampere hour rated, or it may be rated in watt hour rated. So next one is the discharge time of a battery is nothing but energy delivered to the power, which is nothing but gives the discharge time. A 100 Ah battery has high discharge time when used for 100 hours for a current of 1 ampere. So next one, what is meant by state of charge of a battery? This is the amount of charging available in a battery is called state of charge. How much has been discharged is called depth of discharge. If you add state of charge and depth of discharge is equal to 100%. Next one, self discharge. What is meant by self discharge? Self discharge is nothing but the energy lost by the battery whenever it is not used for a longer time. You kept the battery for a longer time without using, then it undergoes self discharge. So the self discharge may be recorded as a percentage of self discharge per day due to its chemical properties. Next one, the life cycle of a battery varies from 1000 to 3000 or 3 years to 8 years. Maximum, if you buy a mobile, maximum 3 years you can use. But electric vehicle also you can use for 3 years, or maximum four-wheeler you can use for 8 years. And ampere hour efficiency is approximately equal to 100%, which is called ampere hour rating of a battery discharge to the ampere hour rating of a battery charge. So this is all about the characteristics, parameters or specifications of an battery. If you feel the content is very useful to us, please like and please share with your friends, and if you have any doubt, let me know in the comment section. And if you are watching the channel for the first time, subscribe to the channel, and this is a free channel and this is not a commercial channel, so please subscribe and share with your friends, which will help us or which will motivate us to do more videos on electric vehicle. Thank you for watching, students. We'll meet in the next class. Thank you for watching. So this is all about the characteristics, properties or the specifications of an electric vehicle battery. Thank you for watching.